Welcome once again to the next video related with the method of preparation. So this is a remaining part of the method of preparation and that of your first method, that is by using this calcium salt of carboxylic acid. Here the aldehyde product is of course accompanied by the ketone and aldehyde. So here is a in general, yield of the aldehyde and ketone in above reaction are low and can be improved by taking the barium and magnesium thorium salt instead of calcium salt. So these are the common system you will get a formaldehyde, but by using this barium, magnesium, thorium salt, you will get more yield than that of calcium. So there is the next catalytic decomposition by using the manganese or thorium. So catalytic decomposition of the carboxylic acid, simple ketone can be prepared in a very good yield, that is 90%, by passing the vapors of the suitable carboxylic acid or the formic acid over a heated the manganese or thorium. So here is the suitable carboxylic acid, manganese or thorium oxide. It will use ketone and remaining byproduct. So there is example acetic acid. In the presence of same reaction condition, it will use acetone. So asymmetrical ketones are obtained by passing the mixture of the vapors other than the formic acid. So here is a asymmetrical two types of the carboxylic acid, same reaction condition, and it will give ethyl methyl ketone, that 2-butane, that is asymmetrical ketone. So yield would be a low since acetone and diethyl acetone are also formed simultaneously. So aldehyde are prepared by passing the mixture of the vapors of a formic acid by, or any other acid over a heated catalyst. So here is heating of this catalyst, manganese oxide, so acetic acid and formic acid, and it will give acetaldehyde and remaining byproduct. So the aldehyde product is mixed with this acetone and acetylene. We can separate it out. Then next is Stephen reduction of nitrile. So it is a method of preparation useful to produce the prepared aldehyde. So alkane nitriles are first reduced ether solution by the hydrogen chlorine gas or stannous chloride, or hydrogen chlorine gas or stannous chloride at a room temperature. So aldehyde hydrochloride produced is filtered off, and then subsequently we will get hydrolyzed with the warm water. So this is the first step using this reaction condition, as we see early in this reaction. So it will give aldehyde hydrochloride, and that will converted into on hydrolysis aldehyde. So it is a two-step process where we get the first aldehyde, on hydrolysis they will get the aldehyde. So this method is not applicable to the synthesis of the ketone. It will only use aldehyde. And next is a Roseman reaction of acid chloride. So aldehyde can be prepared by the reduction of the acid chloride with the H2 gas. So this is acid chloride H2 gas in the presence of palladium catalyst. It will use the barium sulfate. In the presence of barium sulfate, it will use aldehyde at 140 degrees centigrade, but it is a poisonous in nature. So normal aldehyde form would be further reduced to the primary alcohol, but barium sulfate poisonous the palladium catalyst, which is deactivated so as not be permitted to further reduction of the aldehyde product. So this is a Roseman reaction. Formaldehyde cannot be made this method because formyl chloride is very unstable at ordinary temperature. So according to the more recent method, an acid chloride can be reduced to aldehyde using the modified hydrogen hydride reagent, that is lithium tertiary butoxyl aluminum hydride. So we'll get aldehyde. So this reaction is preferred the Roseman reaction as produced at low temperature. So here is a minus 78-degree temperature, and the reduced agent is easily prepared, and it is maybe noted that lithium aluminum hydroxide alone would be reduced the aldehyde product to primary alcohol. So this is the reaction condition only changed by this Roseman reduction method, and we will get the product in this way also as aldehyde. The next reaction is from Grignard's reagent. So already we know MgX Grignard's reagent. Aldehyde can be synthesized by the action of the Grignard's reagent with excess of the formic acid. So this is of a Grignard's reagent, RMgX, that is RMgCl. So it will ethyl format. In the presence of it will use aldehyde RC11OH. So ketone are obtained by the adding the Grignard's reagent to acid chloride. So this is of acid chloride Grignard's reagent. It will give the intermediate compound on hydrolysis. It will give ketone. So recently the organocadmium compound has been used as preparation of ketone. So this is organocadmium chloride in the presence of Grignard's reagent. Since is not react further with ketone product to form alcohol, so it will cadmium Grignards, and this cadmium Grignards further react with this another molecule of the alkyl cadmium Grignard, and it will give the ketonic compound. So reaction of Grignard's reagent with the nitrile and subsequent acid hydrolysis also yields the ketone. The next last reaction that is method of preparation of here is ketone. So from acetoacetic acid, so alkyl derivative of the acetoacetic ester, that is CH3CO CH2 COOCH2 upon hydrolysis with dilute alkalis gives the corresponding ketone. So this is acetoacetic ester in the presence of this dilute alkali with this ketone. Simple reaction is. So all of these reactions are completed related with preparation of aldehyde. So lots of reactions are there. Some of the reaction gives both of aldehyde and ketone. Some of the reaction only gives ketone, or some of the reaction gives only aldehyde. Then important point related to this carbonyl compound is the physical property. So let us discuss about the physical property. So listen that the formaldehyde, the first member of the aldehyde series, is a gas at a ordinary temperature, while the acetaldehyde boiled at a 21 degree. So we'll get idea about the nature of this formaldehyde and other compound. So the next 9 member, that is from C3 to C11, are liquid, and the higher members are in solid. So apart from the C3, we'll get the changes the physical property. So ketones upon C11 are colorless mobile liquids, and the higher members are the solid. So higher members are solid, but up to the C11s are colorless mobile liquids are there. The lower aldehyde possesses the unpleasant, if we consider the odor, so unpleasant odor, lower aldehyde. But as we goes upon the series higher series, so it will give smell, becomes a more and more fruity. So the ketones are generally pleasant smell liquid. The higher aldehydes from the C8 to C13 and the ketone are used in a perfumery industries because it is having the pleasant odor. Then the first few members of the aldehyde and ketones series are insoluble in water, but solubility falls with the increase in the size of the hydrocarbon attached to the carbonyl compound or carbonyl group. So thus those which having 5 or more carbon atom are sparingly soluble in water. So first few members are aldehyde and ketones are soluble in water, but apart we goes series up then it will not. The solubility of aldehyde and ketone is accounted attracted for by the electrostatic attraction between the polar carbonyl group and the water dipole. So this is depending upon the dipole moment and the carbonyl group. So beyond the carbon, however, the electrostatic forces of attraction, the polar group and the water dipole are insufficient to hold the molecule in the solution, and hence the larger hydrocarbons like a nature of the alkyl group becomes dominant in that case. So the electrostatic forces of attraction between polar group and water insufficient in that case to hold them. Then aldehyde and ketones being quite polar, that is aldehyde 2.70 dipole and acetone is 2.85 dipole. So there is a good deal of the intermolecular association due to the electrostatic attraction between the opposite end of the C double bond. So it will form partial positive and partial negative charge in between them. So hence the boiling point of the carbonyl compound higher than the non-polar alkane of the comparable molecule weight. The dipole moment, dipole attraction between the molecule of the aldehyde or ketone, however, it is weaker than the analogues of the hydrogen bonding attraction between the alcohol molecule. So thus, there is difference in between those dipole moment and dipole attraction. Boiling point of the carbonyl compound are lower than those of the corresponding alcohols. So illustration, acetone and other compound are easily evaporated. So boiling point is low in case of corresponding aldehyde and ketone. So in general, melting point, boiling point members of both of aldehyde and ketone series shows regular increase as ascent and reactive series. So physical constant of the sum of the carbonyl are given in this table. So there is, we get a difference in between the formaldehyde, acetaldehyde and series of the aldehyde and ketones goes up to higher series. So boiling point becomes changes from this. So here is a boiling point. So there is a melting point will differentiate according to the because of series of size of the aldehyde and ketones. So so this is related with all the physical properties and some of the method of preparation. So in next video we will see the remaining part of this carbonyl compound, that is the chemical properties. So thank you for listening this video.